In 2006, we voted to demote Pluto. We decided it wasn't important enough to deserve a place at the table. Then James Webb pointed its golden mirror at it. And what came back through that mirror is something that nobody, not a single scientist on Earth, was prepared for. Most people think Pluto is boring, a frozen rock, a failed planet, a footnote at the back of a textbook that nobody bothers to read. That assumption is about to cost you something, because James Webb didn't just observe Pluto. It found a bleeding world slowly feeding its own atmosphere to a poisoned moon across 12,000 miles of absolute silence. It found organic chemistry falling from the sky like snow, the same chemistry that may have triggered life on early Earth. It found evidence of something that should not exist on a world this far from the sun, this cold, this supposedly dead. I'll tell you exactly what Webb found, all of it. But first, you need to understand what we thought Pluto was. Because without that, you can't appreciate how completely James Webb just shattered everything. Pluto was discovered in 1930 by a 24-year-old Kansas farm boy named Clyde Tombaugh, a man with no college degree, who spent night after night in an observatory in Flagstaff, Arizona, comparing photographic plates and hunting for a single dot that moved against the background stars. When he found it, the world had its 9th planet. For the next 75 years, almost everything we knew about Pluto was a guess. It was a smudge of light, too small to resolve, too far away to reach. We knew it was cold. We knew it was small, about 2/3 the size of our moon. We knew its orbit was a strange, tilted ellipse that swung it inside Neptune's path for 2 decades at a time, before flinging it back out past 4 billion miles from the sun. Beyond that, Pluto was a placeholder, a name on a wall chart. Then in 2006, the very same year we stripped it of its planetary status by committee vote, we launched the only spacecraft ever sent to visit it. We decided it wasn't worth full membership, and then we sent a probe to go look at it anyway. It took 9.5 years to arrive. What it found would change everything. In July 2015, New Horizons screamed past Pluto at over 30,000 miles per hour and gave us our first real look at a world that had only ever been a blur. What it photographed was not the dead rock anyone expected. There was a heart on the surface, an enormous, pale, almost pristine region shaped almost exactly like a valentine, stretching 1,000 miles across, glowing against the darker terrain like something had placed it there deliberately. Mountains rose nearly 11,000 feet into the thin sky, taller than any peak east of the Mississippi, carved entirely from water ice frozen so hard it behaved like granite. Plains of nitrogen ice flowed across the surface in churning, cell-like patterns, slowly resurfacing themselves in a way that hinted at warmth somewhere beneath. A thin nitrogen atmosphere wrapped the world in dozens of layered hazes, blue against the black of space, rising hundreds of miles above the surface. Pluto wasn't a frozen corpse. It looked alive. But something didn't add up. Scientists had built careful models of what Pluto's atmosphere should look like. Based on its composition, nitrogen, methane, carbon monoxide, those models predicted temperatures around 100 Kelvin, -173 degrees Celsius. Cold but reasonable. When New Horizons actually measured it, the atmosphere was sitting at 65 to 70 Kelvin, a gap of more than 30 degrees. Something was cooling Pluto's atmosphere far more efficiently than any model on Earth had predicted. For years, nobody could explain it. Then, in 2017, a scientist named Shi Zhang at UC Santa Cruz proposed something that most of the field considered almost too strange to take seriously. I'll tell you what he proposed. But to understand why it took the most powerful telescope in human history to prove it, you first need to understand what's actually happening in that atmosphere. Because the answer involves something that falls from Pluto's sky like snow, and it's not water. Even though sunlight at Pluto is 1,000 times dimmer than on Earth, so faint that noon on Pluto is darker than the worst overcast evening you have ever stood in, ultraviolet rays still reach it, and they have just enough energy to do something subtle and consequential. They break apart methane molecules. When a methane molecule gets hit by UV light, it splits into fragments. Those fragments don't float away. They react with each other, combining into progressively heavier hydrocarbons, ethane, acetylene, ethylene, a whole zoo of increasingly complex molecules that grow heavier and heavier as they fall through the thin atmosphere toward the surface. Eventually, these compounds clump together into solid tar-like particles called tholins, reddish-brown organic matter, drifting downward through Pluto's sky like a 4 billion-year chemical snowfall, coating the surface layer by layer in frozen organic chemistry. These tholins are what give Pluto its color. They are also the same class of molecule that scientists believe rained out of early Earth's atmosphere, and may have contributed to the chemical soup from which life later emerged. On Pluto, they fall endlessly, dropping the raw ingredients of biology onto a world too cold for any of them to ever do anything. The chemistry of life, frozen mid-step, an experiment running in silence for longer than complex life has existed on Earth. Now here is where Xi's controversial idea enters. Zhang proposed that Pluto's haze wasn't just drifting passively in the sky. He argued it was actively controlling the planet's temperature. These tiny particles, he suggested, were absorbing sunlight and re-emitting that energy as heat, not as visible light, but as mid-infrared radiation. In an atmosphere this thin packed with these particles, that process could cool the entire atmosphere far more efficiently than gases alone ever could. It was radical. Until then, every planetary climate model ever built assumed that gases dominated temperature control. The idea that solid particles could run an entire atmosphere's energy budget seemed almost impossible, and there was no way to test it, because confirming mid-infrared emissions from Pluto's haze required a telescope of extraordinary sensitivity, one that could separate Pluto from Charon sitting close beside it, and isolate just the thermal signal from that thin atmospheric haze. No telescope on Earth could do it. No telescope in orbit could do it. Not until 2021. James Webb is not a flyby spacecraft. It doesn't take portraits, it takes fingerprints. Every wavelength of light a planet reflects or emits carries a chemical signature. And Webb, with its 6.5-meter gold-plated mirror orbiting the Sun 1.5 million kilometers from Earth, is built to read those signatures with a precision no instrument in history has possessed. It doesn't need to fly to Pluto. It just has to stare at the right pinprick of light and let the photons do the work. In May 2023, an international team led by Tanguy Bertrand pointed Webb toward Pluto and Charon. For the first time ever, scientists could clearly separate the two worlds in infrared light. This sounds technical, but it matters enormously. Every telescope before Webb had blurred the distinction between Pluto and Charon, making it impossible to determine which thermal signal was coming from which body. Webb's mid-infrared instrument, MIRI, can detect light in exactly the range where Pluto's haze particles would emit heat. If Zhang's 7-year-old theory was correct, the team built a precise model of Charon's thermal signature, subtracted it from the total observation, and what they were left with was a clean, isolated picture of Pluto's own mid-infrared emission. What they found confirmed what had been speculation for nearly a decade. The infrared glow coming from Pluto was stronger than its icy surface alone could produce. Something above the surface, something in that thin layered atmosphere, was radiating heat into space. And when they mapped that emission across 4 different infrared wavelengths, the data matched the model with near-perfect precision. Pluto's haze is not passive. It is actively bleeding heat off the dwarf planet. Zhang's crazy idea was right. The atmosphere of Pluto is being chilled not by its gases, but by the solid particles suspended inside it. For the first time in the history of planetary science, we have found a world where haze, not gas, runs the entire climate system. On Earth, on Mars, on Venus, on every other world we have ever studied, gases do the heavy lifting. Haze is background scenery. On Pluto, haze is in charge, and it gets stranger from here. Here is something that has been hiding in plain sight for decades. Pluto's largest companion is its moon Charon, a battered ice world about 750 miles across, locked in a tight gravitational dance with the dwarf planet. Charon has no atmosphere of its own. Its surface is bare, ancient, cratered water ice, and yet its north and south poles are stained with a strange reddish-brown deposit, darker than anything else on its face. For decades, planetary scientists had a hunch about where that color came from. They suspected it had something to do with Pluto. They could never prove it. Webb proved it. In papers published in 2024 and 2025, the same team that confirmed Pluto's haze cooling effect also mapped exactly what was happening to Pluto's escaping atmosphere. Pluto is leaking, slowly, constantly, every second of every day. Methane and other molecules drift upward from its atmosphere, escape its weak gravity, and drift across the roughly 12,000 miles separating the two worlds. Charon's gravity catches them. They freeze onto its poles. Then sunlight and cosmic radiation crack them apart, triggering the same chemical reactions that produce tholins, reddish-brown organic compounds that paint Charon's poles with Pluto's own stolen chemistry. Charon's red caps are made of Pluto's breath. Nothing else in the solar system does this. No other world is bleeding its atmosphere onto a moon and painting that moon with the leftovers. Pluto and Charon are locked in a slow, quiet, vampiric exchange that has been running for billions of years, and we only just figured it out. But Webb didn't stop there. In October 2024, a separate team confirmed the presence of carbon dioxide and hydrogen peroxide on Charon's surface, manufactured by radiation dismantling Charon's own water ice and rearranging the atoms into new compounds. Carbon dioxide, the gas you exhale, hydrogen peroxide, the bleach you pour on a wound, both sitting frozen on a poisoned moon billions of miles from Earth. Relief, we have explained the red caps. Then, deeper tension. Because what Webb found next changes the entire question of what Pluto actually is. Here is the most controversial claim in modern planetary science. Pluto may have a liquid ocean, not on its surface, not anywhere we can see, but possibly buried 100 miles beneath the ice, kept warm by the slow decay of radioactive elements in Pluto's rocky core. An ocean that has been sitting in complete darkness under enormous pressure for over 4 billion years. The evidence keeps building. The pattern of cracks and ridges on Pluto's surface is consistent with the kind of stresses you'd expect from a subsurface ocean slowly freezing outward, expanding and fracturing the crust above it. The shape of Sputnik Planitia, the western lobe of the famous heart, points to a positive gravity anomaly beneath it, something denser than the surrounding ice. Liquid water fits the math. And then there are the mountains nobody can explain. South of the heart, two enormous isolated peaks rise from the terrain. Wright Mons, roughly 13,000 feet tall. Picard Mons, possibly close to 20,000 feet, with a base that rivals Mauna Loa, the largest active volcano on Earth. Both have deep central depressions at the summit, concentric fractures, flanks that look exactly like cooled lava flows. They may be cryovolcanoes, mountains that erupted not magma but a slurry of water, ammonia, and methane pushed upward from somewhere deep beneath the crust. Something forced liquid material through the ice in the geologically recent past. Pluto, the world we thought was completely dead, has a heat source. We don't know when those mountains last erupted. We don't know if they still do. If that buried ocean exists, it has been there for billions of years, dark, salty, sealed from the universe by a shell of frozen rock harder than anything on Earth, fed by organic compounds, drifting down from the surface through cracks in the ice. One of the most promising environments in the entire solar system for conditions under which life could arise independently of a star. We cannot reach it. Not yet. There is no Pluto orbiter, no lander, no funded mission. The journey takes a decade. The engineering is monstrous. The budget for outer solar system science has been shrinking for years. Webb is the best tool we have. And every time Webb stares at Pluto, the picture gets stranger. Every single pass. If you could somehow stand on Pluto's surface, here is what you would experience. The sun would be visible, but only as a piercing point of light. Brighter than any star in our sky, but smaller than a pinhead held at arm's length. No warmth, no glare. You could stare directly at it without flinching. The sky would be a permanent grey-blue twilight, neither day nor night. A gloom that never lifts. The ground beneath your feet would not feel like Earth. Water ice at negative 380 degrees Fahrenheit is not slippery. It is rock. It rings like steel when struck. To the east, if you walked far enough, you would enter a field of ice spikes, methane blades reaching 500 feet into the sky. Similar formations on Earth rarely grow taller than a person. Pluto's versions are dozens of times larger. A belt of frozen knives ringing the entire equator. Above you, Charon would hang in the sky and never move, looming. Always the same face turned toward you. A frozen grey eye that never blinks. If you tried to breathe, there would be essentially nothing to breathe. The atmosphere is 100,000 times thinner than Earth's. But that would be the second thing that killed you. The first would be the temperature. Exposed skin would freeze faster than it could register pain. Your tears would crystallize before they fell. Your blood would slow, then thicken, then stop. And then it would snow on you. Not water snow, nitrogen snow. The same nitrogen filling your lungs right now, drifting from the sky and settling on your frozen face as fine white powder. The very chemistry of the air you breathe is the chemistry of Pluto's surface. Frozen, lying quietly on the ground. You started this video thinking Pluto was a demoted footnote at the edge of nothing. Now you know what it actually is. Let every thread come together. Pluto's atmosphere is cooled by haze, not by gases. A mechanism never seen on any other world, confirmed for the first time by Webb's MIRI instrument after 7 years of being called a crazy idea. Pluto is actively leaking its atmosphere into space, and Charon is catching it. With Webb confirming that Charon's mysterious red poles are literally made from Pluto's stolen molecular breath, and hydrogen peroxide on Charon's surface manufactured by radiation rearranging the atoms of its own ice into atom compounds we associate with breathing and with bleach.
Pluto has possible cryovolcano, Cantus, Pard, mountains that may have erupted liquid slurry from beneath the crust, suggesting an internal heat source in a world we declared dead. Evidence continues to build for a buried liquid ocean, possibly 100 miles deep.
Kept warm by radioactive decay, one of the most promising environments in the solar system for life independent of a star. The organic chemistry Webb is watching happen on Pluto right now. Tholins raining from the sky for 4 billion years is the same class of chemistry believed to have seeded life on early Earth. Pluto may be one example among trillions. The Kuiper Belt contains hundreds of thousands of similar objects, each one potentially performing some version of this same slow, silent chemistry in the dark. And here is the part that gets me every time. That 4 billion year chemical snowfall. Those tholins raining from Pluto's sky. The same organic molecules scientists believe contributed to the chemistry that eventually produced life on Earth. We are, in some sense, made of the same conversation that Pluto is still having with its own sky. The same chemistry, the same molecules, the same slow accumulation of complexity in the dark, just at different temperatures, different distances, different timescales. Pluto is not a postscript. It is a warning about scale, about how much we have been wrong about how many worlds are out there in the dark, quietly doing things we haven't imagined, on timescales that dwarf all of human history. Alan Stern, the principal investigator of New Horizons, said that 2015 photographs would haunt him for the rest of his life. Webb has taken that haunting and made it permanent. The data keeps coming. Every pass tightens the model. Every pass adds another layer to the question of what is actually happening out there. And every pass so far has made Pluto stranger than it was the day before. We voted to demote it. James Webb just showed us we had no idea what we were dismissing. There are trillions of worlds out there in the dark, each one doing something, and we have barely started to look. We named it after the god of the underworld. Turns out, we had no idea how appropriate that was. Thanks for watching. See you in the next one.